Okay, here we're doing grade 11 maths paper 1, the 2018 paper. Let's start with question 1, which is algebra. Okay, so 1.1 says x times 2x plus 1 equals to 0. Okay, so this is a quadratic equation, and how do we solve it? Well, they've already factorized it for us, so we have two factors. We have x and 2x plus 1. Okay, now remember, if you multiply two numbers together, let's say a and b, and they have to equal to 0, the only way for this expression to equal to 0 is if one or both of the numbers are 0. Okay, so if, for example, if I have a times 0, so we're saying that b is 0, then we'll get 0. Or the other way around, let's say I have 0 times b, that will give us 0, or 0 times 0 gives us 0. Okay, so that means that either one of these factors have to equal to 0. So I'm going to say x equals 0 or 2x plus 1 equals 0. Okay, so this is already solved, and on this side we just bring this to the other side and divide by 2. So we'll say x is equal to minus half. Okay, so that's our two answers. Okay, next question, 1.1.2. 1.1.2, you can see it's another quadratic equation. And see, for this one here, it's trinomial, it's not yet factorized. So the easiest way to solve something like this is to just use the quadratic formula, which is minus b plus or minus the root of b squared minus 4ac all over 2a. Okay, so now we just substitute in. So we'll have x is equal to minus b, so minus 2 plus or minus the root of, and then b squared, so 2 squared is 4, minus 4a is 5, and c is minus 6, all over 2a, so 2 times 5. Okay, let's simplify that a bit. So I'll have minus 2 plus or minus the root of, and now I'm just going to put all of that into my calculator. So I'll say 4 minus 4 times 5 times minus 6, and that gives us 124 over 10. Okay, now I can split this up. So I can say x is equal to minus 2 plus the root of 124 over 10, or x is equal to minus 2 minus the root of 124 over 10. Okay, so let's evaluate each of those on our calculator. So I'll have minus 2 plus the root of 124 over 10, and that gives us 0.91, or minus 2 minus root of 124, and that gives us negative 1.31. Okay, and then you obviously, now you can take these two x values and substitute it in this original equation, right? So you can start with 0.91 and put it in place of x and see if you get 0, and then do the same for this, and if they come to 0, that means your answers are correct. Okay, let's do the next one. 1.1.3, that's an inequality. So we'll have 2x squared minus 2 is greater than or equal to 3x. Okay, so it's going to be quadratic as well. So we can start by making this 0. So let's just bring this minus 3 to the side. Minus 3x minus 2 is greater than or equal to 0. Okay, now the first thing here that you have to do is find what's called the critical values. So you first have to find when this expression is equal to 0. Okay, so we'll say 2x squared minus 3x minus 2 equals 0. Okay, and now you can either use the quadratic formula, or you can just find common factors and do that. I'm just going to use the quadratic formula here. So minus b plus minus the root of b squared minus 4ac all over 2a. So I'll have 3 plus or minus 9 minus 4ac all over 2a. Okay, and I'll put this part here under the square root into my calculator. So 9 minus 4 times 2 times minus 2 gives us 25 over 4. Okay, so that means we'll either have x equals to 3 plus 5 over 4, or x is equal to 3 minus 5 over 4. And I'm saying 5 because the square root of 25 is 5. Okay, so this side will give us 2, and this side will give us minus a half. Okay, so now let's think about this. So the original equation that we had, if you think about functions, what function does this look like? This is a concave up or a happy parabola, right? So I'll draw in the x-axis here, and let's look at the question. They're asking for the values where this parabola is greater than or equal to 0. Okay, so if we look at our parabola, what did we solve for when we solved for x? Well, we equated it to 0. And when does the parabola equal to 0? At the x-intercepts. Okay, so the two values that we solved for here, those are the x-intercepts. So this is minus a half and this is 2. Okay, and the question is asking for when this parabola is greater than or equal to 0. Okay, so this occurs at these values here. Right, because if you look at it, everything beyond this point, beyond the x-intercept this way, the parabola is greater than 0, and anything beyond this point, it's also greater than 0. Okay, and obviously at the x-intercepts they equal to 0, so that satisfies our two things. So we can see that therefore x either has to be less than or equal to minus half, or x has to be greater than or equal to 2. Okay, and that's our final answer. Okay, 1.1.4. So this says root of 2x plus 5 minus 3 over root of 2x plus 5 equals to minus 2. Okay, so if we look at this nicely now, you can see that we have this repeated twice, that root of 2x plus 5. Okay, so what we can do is we can set that. We can say let the root of 2x plus 5 equal to, let's say, k. Okay, you can pick any variable, but let's just say k. So now we're going to rewrite this expression on top here, but in place of root of 2x plus 5, we're going to say k. So k minus 2 over k equals to minus 2. Okay, and now we can just solve for this as if we were just solving for k. So let's get rid of this denominator by multiplying through by k. Okay, let's bring this to that side. K squared plus 2k minus 2 equals 0. Okay. Oh, so I realized this is supposed to be 3, sorry. So this is 3, this will become 3 then, and this will become 3 as well. Okay. And now we can, let's just use some common factors for this one. Okay, so remember when we try and expand this trinomial, we have to find two numbers that when you add them together, it must give you that minus 3. And when you add them together, it must give you 2. And when you multiply them, it must give you minus 3. Okay, so what two numbers is that? Well, let's think about the factors of 3. So 3 only has 3 and 1. It's a prime number. Okay, so that means that the only factors we can think of would be 3k minus 1k or k. Okay, so if you look at that now, if I take 3 and multiply it by minus 1, I'll get minus 3. And if I take 3k, or if I just say 3 minus 1, I'll get 2. Okay, so that's this. Okay, so you can see when I add them, I get to 2, and when I multiply them, I get to minus 3. So that means that this is going to work. Okay, so let's just factorize this now. So we'll have k plus 3 minus 1, k plus 3, and it's equal to 0, equal to 0. And now I can factor out the common factor of k plus 3, and I can equate them both to 0. Okay, so okay, so we got till that point, but remember up here we said that k is equal to 2x plus 5. So now we're going to take each of these equations and equate them to our original thing. So we can say root of 2x plus 5 equals to minus 3, or the root of 2x plus 5 equals to 1. Now right off the bat we can immediately discount this solution, okay, because if you think about it, we have a square root of something and we're getting a negative answer, which is impossible, right? There's no way to get the square root of something and get a negative answer. Okay. So this is not possible, so there's no solution on this side. On this side we can still keep solving, so let's square both sides. So we'll have 2x plus 5 equals to 1, and then we can just solve for x here. So minus 5 on that side, so 1 minus 5 is minus 4, and then divide by 2, you'll get minus 2. Okay, now you can take this answer of x equals minus 2 and you can test it in this original equation up here, and if you substitute in x and you get minus 2 at the end, that means that your answer is correct. Okay, let's look at the next one. It's a simultaneous equation. So, okay, so two equations are, this is 1.2. Our two equations are y plus x equals 2 and x squared plus 3xy plus 8 equals 0. So x squared plus 3xy plus 8 equals 0. Okay, so let's isolate one of our variables. So here I'll just isolate y, but you can do it for x as well. So we made y the subject of the equation. We call this equation number 1. We'll call that equation number 2. Okay, so now let's say sub equation number 1 into equation number 2. So I'm going to rewrite equation number 2, but in place of y, I'm going to put our new equation. Okay, so x squared plus 3x times 2 minus x plus 8 equals 0. Okay, so now I have x squared plus 6x minus 3x squared plus 8 equals 0. Okay, group my like terms and add them, so I'll get minus 2x squared plus 6x plus 8 equals 0. Okay, and then I can divide away by minus 2 because it goes into each of those just to simplify things a bit. So I'll get x squared minus 3x minus 4 equals 0. Okay, and again we're going to look for a number that when you add it, it gives us that, and when you multiply them, it gives us minus 4. So x squared minus 4x plus x minus 4 equals 0. Okay, let's see if that makes sense. If I take minus 4 plus 1, I get minus 3, and if I take minus 4 times 1, I get minus 4. Okay, so there's my minus 3 and there's my minus 4. So that means that these two numbers are going to work. Okay, so now it's just a case of factorizing everything. And now we can take out our common factor. Okay, again we can equate each of these to 0 and we get two answers, right? And now at this stage you can test if your answers are correct. So you can take 4 and minus 1 and sub it in wherever you see x. So you start with 4, wherever you see x you substitute it in, and if you get 0 that means your answer is right. And then you do the same for minus 1. Okay, but anyway, once you get your answers, now you can call this equation number 3, call this equation number 4. Okay, so take sub equation 3 into equation 1, which was this equation here, and at the same time you can sub equation 4 into equation number 1. Okay, so equation number 1 is y equals to 2 minus x, right? But now in place of x we're going to put 4. Okay, so that means y equals to minus 2. And on this side, y equals to 2 minus x. So in place of x, we're going to put minus 1. Okay, so y equals to 3. So that's your answers there. So you're going to end up with 4 answers, 2 x values and 2 y values. Now to test if your answer is correct, you start with, let's say this first case here, where you have x equals 4 and y equals minus 2, right? So you come into this first equation, you sub in minus 2 for y and 4 for x, and you should get 2. And here you sub in 4 for x and minus 2 for y, and you should get 0. Okay, and then you do the same for that. And if you get the right answers, that means that your answers are correct. Okay, now we're going to look at question 1.3. So there's the question. It says the roots of the equation f of x equals 0 are x equals to 4 plus or minus the root of 16 minus 4m, all multiplied by minus m plus 5, and then the whole thing is over 2m. Okay, it says determine the values of m for which the roots will be non-real. Okay, so remember, for something to be non-real, it means that it's mathematically not possible. Okay, so if we look at this expression here, how would these roots be non-real? Well, let's take a square root of something, right? What is the square root of something? Let's say the square root of x squared. That's x, right? Because I have to take x times x to get to x squared. Okay, so you can see I multiplied the same thing twice to get to x squared. Okay, now think about this. Is it possible to multiply two numbers and get a negative answer? Okay, let's say for example negative x. The answer is it's not possible. Okay, because if we take two positive numbers, let's say x and x, I'll get to x squared, right? Positive x squared. Okay, and if I take minus x times minus x, I'll also get to x squared, right? Because negative times a negative is a positive. Okay, so it's impossible to multiply the same number twice and have it be negative. So that means that for this to be non-real, whatever is under this bracket has to be less than 0, meaning that it's negative, and that will make it non-real. Okay, so let's say 16 minus 4m times m plus 5. Thus here has to be less than 0. Okay, so now it's a simple case of just solving for m. So let's multiply all of this out. Okay, let's rearrange this so that it goes like that, and let's equate it to 0. Okay, because much like the other question, we're going to find the critical values first. Okay, so I can use factors here again to solve for this here. Okay, but before I even do that, let's first make this a bit simpler. Let's say m squared minus 5m plus 4. Okay, and why did we do that? We just divided everything by 4. Okay, just to make it a bit simpler. Right, now again, we need to find two numbers that when you add them together, you get to minus 5, and when you multiply them together, you get to 4. Okay, and what two numbers are that? Well, let's think. Let's try minus 4m minus 1m, right? Now if I take minus 4 minus 1, I get minus 5. And if I take minus 4 times minus 1, I get 4. So that means that works because I get minus 5 when I add them and I get 4 when I multiply them. Okay. So now it's just a case of factorizing everything and then taking out the common factor and then equating them both to 0. So m equals 4 or m equals 1. Now again, let's look at this here. What is this? This is a upwards facing parabola. Okay, it's a concave up parabola. Right, because I have a positive coefficient of m squared. Okay, let's drop in our x-axis. And again, where is it equal to 0? When we are at the x-intercept. Right, so this is at 1, this is at 4. And if we look at the question again, we're looking for when this is less than 0. So when is the graph less than 0? Well, it's less than 0 when it's in this range here. Right, when it's between 1 and 4. So we can say that m has to be greater than 1 but less than 4. And that's our answer. Okay. Okay, let's look at the next question, 1.4. It says, show that the maximum value of the root of minus x squared plus 4x plus 12 is 4. Okay, so the easiest way to do this is to look at this and get rid of the square, this square root. Okay, so that's instead of saying when is this thing, or let's instead of proving that the maximum of this is 4, let's prove that the maximum of minus x squared plus 4x plus 12, so I just squared this whole thing, is 16. So 4 squared. Okay, so that's a bit easier to do because if you look at this now, this is just literally a downwards facing parabola. Okay, look at it. If we have a negative coefficient of x squared, that means it faces down, so there is a maximum value, right? Upwards facing parabola, sorry, let's just use this as an example. This upwards facing parabola here will have a minimum value, okay, and a downwards facing one will have a maximum value. Okay, so how do we find the maximum value of a downwards facing parabola? Well, it's at the turning point, right? Because remember, if you go from here, if you start this way and you move up, you're going to increase to a certain point, that's the height, and then from there it keeps going down. So at the turning point is the maximum. Okay, and how do we find the turning point of a parabola? Well, there's a few ways. Let's just use this way here. So the turning point, the x value of the turning point equals to minus b over 2a. Okay, so minus b in this case will be minus 4 over 2a, so 2 times minus 1, right? And the answer to that is 2. Okay, so the x value of this turning point here, remember this turning point is an x and a y value, so that x value is 2. And now we just have to solve for the y value to get the maximum point. So I'll take this 2, and now it's very much like a functions question. I'm going to take this 2 and I'm going to substitute it into that equation. Okay, so I'm going to say minus 2 squared, so y equals to plus 4 times 2 plus 12. Okay, and if I evaluate that, I get minus 4 plus 8 plus 12. and that gives us 16. Okay, so we prove now that so we can say therefore the max value of minus x squared plus 4x plus 12 is 16. Therefore the max value of the root of minus x squared plus 4x plus 12 is the square root of 16, so 4. Okay, and that proves what we were asked to show, right? We were asked to show that the maximum value of that is 4, and we've done that, so that's the correct answer then. Okay, let's now look at question 2. So simplify fully without using a calculator. Okay, I've just rewritten the question there. It's 2 to the x minus 3 times 2 to the x plus 1 all over 2 to the x minus 2. Okay, so to solve these, the first thing to do is to break up these into simpler expressions. Okay, so how did I do that? Let's think about the rules of exponents. Let's say I have something like a to the m times a to the n. That's the same as saying a to the m plus n. Okay, so in this case I basically did that in the reverse. I already had it in this form here and I broke it down. Okay, so if I look at this, I have a common base of 2 and I can add the exponents and it will give me x minus 3. Okay, so that's how I'm going to do it for the rest of these as well. So now I can say 3 times 2 to the x times 2 to the 1. Okay, and remember 2 to the 1 is the same as 2. Okay, and the reason these are going in brackets is because remember this 3 was multiplying the whole 2, so now it has to multiply each of those. Okay, now I can break up the bottom one as well, so 2 to the x and 2 to the minus 2, and now I can simplify the top a bit, so 2 to the minus 3, and now I can just multiply those and make it 6 because it'll just make everything a bit simpler, right? At the bottom we can't really change much, so we'll just leave it as is for now. But let's come back to the top. Now you can see we have two terms. I have this term and I have this term, because remember a term is separated by either a plus or a minus. Okay, and if I look at that, I have a common factor between those two terms. So let me factorize that. Okay, all over 2 to the x times 2 to the minus 2. Now if I look at this, 2 to the x is common between the numerator and the denominator, so I can cancel it. Okay, and then that leaves us with 2 to the minus 3 minus 6 all over 2 to the minus 2. Okay, now how do I make these negative exponents simpler? Well, remember this law here. Let's say I have a to the minus m. That's the same as 1 over a to the m. Okay, so I take 1 over and then a to the base to the exponent, but now I get rid of the minus. Okay, so for 2 to the minus 3, that will become 1 over 2 to the 3, and 2 to the 3 is just 8. Okay, and for 2 to the minus 2, I'll have 1 over 2 squared, and that's the same as 1 over 4. So let me come back into this expression here and substitute that in. So instead of saying 2 to the minus 3, I'll say 1 over 8, and instead of saying 2 to the minus 2, I'll say 1 over 4. Okay, now to keep this simple, I'm just going to substitute all this into my calculator, but make sure that you enter in the fractions correctly. Okay, so it's 1 over 8 minus 6 all over 1 over 4, and that gives me an answer of minus 47 over 2. Okay, and that's the correct answer. Okay, let's now look at question 2.2. So our goal here in each of these is to solve for x. Okay, so 2.2.1, we have 2 minus 16x to the power 3 over 2 equals to 0. Okay, so let's start by putting these on each on their own sides. Okay, so I put 2 equals to 16x to the power minus 3 over 2. Okay, and remember our goal here is to try and isolate x. Okay, so the first thing to do is to get rid of this coefficient. So let's divide both sides by 16. So on this side I'll have 1 over 8 equals to x to the power minus 3 over 2. Okay, because remember this was 2 over 16, so that's the same as 1 over 8. Okay, now 2 over 8, that's the same as 2 to the minus 3, right? Because it's just reversing. If you normally had this expression, that would be the same as 1 over 2 to the 3, which is the same as 1 over 8. So I just did that in reverse. Okay, and then this is still equal to minus 3 over 2. Now let's talk about how to get rid of this ugly looking exponent. Remember, I said the goal is to isolate x, okay? And that's the same as x to the power of 1, right? Those two are the same thing, okay? So how do I take x to the power minus 3 over 2 and convert that to x to the power of 1? Well, I do that by finding something to multiply this exponent by that will give me 1, okay? Now, to make something 1, you basically have to multiply it by its reciprocal. So what does that mean? So I'll multiply it by its reciprocal, which means that I take the denominator and make it the numerator, and I take the numerator and make it the denominator. Okay, and I keep whatever sign it has. So if it is minus, I keep it as minus. So let's see what that does. 3 times 2 is 6, 2 times 3 is 6. Okay, and a negative times a negative will leave it as positive. So I'll have 6 over 6, which is the same as x to the 1. Okay, so let's do the same thing here now. I'm going to multiply this by minus 2 over 3. Okay, it's a reciprocal. But now remember, whatever I do on the right side, I have to do on the left side. Okay, so let's do it on the other side as well. Let's multiply this by minus 2 over 3. Okay, so on this side I'll have 2 to the power of, the minuses will cancel each other out, and the 3's will cancel each other out. So I'll just have 2 to the 2 on this side. Okay, and here I'll have x, because remember that's what we're trying to get to. This is going to cancel each other out. Okay, and then 2 to the 2 is just 4. Okay, so x is equal to 4. Now again, you take your answer, you substitute x, here you put 4, and if you get 0, that means your answer was correct. Okay, let's move on to 2.2.2. It says 4 to the x plus 8 equals 9. 4 to the x plus 8 equals to 9 times 2x, 2 to the power of x. Okay, so to simplify this here, let's start making this a bit simpler. Okay, so let's say 2, remember 4 is just 2 squared. Okay, so 2 squared to the power of x, and we can just write that as 2 to the power of 2x. Okay, plus 8 equals to 9 times 2x. Okay, so let's bring this to this side here. So this will become minus 9 times 2 to the power of x plus 8, there's a plus 8, equals to 0. Okay, now let's say let 2 to the x equal k, for example. Okay, and the reason we're doing that is because remember this can be written as, this here can be written as 2 to the power of x times 2, right? So it's basically 2 to the x squared. Okay, so just keep that in mind. So if we have if we're setting 2 to the x as k, this will now become k squared, right? Because remember I said this can be written as 2 to the x squared. Okay, and then this will become minus 9k plus 8 equals 0. Okay, and now it's a simple case of solving this. So let's find two numbers that when I add them together I get minus 9, When I multiply them, I get 8. Okay, so let's try. K squared minus 8k minus k plus 8 equals 0. Okay, so if I take minus 8 minus 1, because remember saying minus k is the same as saying minus 1k, that'll give me minus 9. And if I take minus 8 times minus 1, that'll give me 8. Okay, so when I added them, I got minus 9. When I multiplied them, I got 8. So that means those will work. Okay, so let's get rid of this. And now it's a simple case of just factorizing. So okay, so I have k minus 8, k minus 1, because this was a common factor, so I factored it out, equals to 0. Okay, so I have two things now. I can equate each of these to 0. Let me just make this a bit neater. So this was k minus 8. Okay, so my two options are k is equal to 8 or k equals 1. Okay, now I'm just going to take this and bring it here. So let's start with k equals 8, right? And remember, k is 2 to the x. Okay, so I could say 2 to the x equals 8 or 2 to the x equals 1. Okay, now this is a simple thing of just trying. So 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. So therefore, x equals 3. And on this side, remember, if I raise anything to the power of 0, it gives me 1. So x equals to 0. Okay, so there's our two answers. Now again, you take it, you substitute it into x, and it must give you, or you can put it in here, and it must give you 0. And you try that for each one, and then you'll know if your answers are correct. Okay. Let's now look at 2.2.3. So I'm just going to do it over here. Okay, so 2.2.3. The root of the xth root of 9 equals 243. Okay. Now how do we solve this? This looks very ugly, but I assure you it's very easy. Okay. Firstly, let's understand what does the sign mean. Okay, in the context of exponents, remember if I say, let's say I say the root of x, right? That's the same as saying x to the power half. Okay, if I say the third root of x, that's x to the 1/3. Okay, and so on. So if I say the xth root of 9, that's the same as saying 9 to the power 1 over x. Okay, so let's keep that in mind. But before we even do that there, let's simplify what's inside the root. Okay, 9 is the same as 3 squared. Okay, and 243, if you do some trial and error, you'll realize that it's 3 to the power of 5. Okay, so let's call this, instead of saying 243, let's say 3 to the power of 5. Okay, now let's recall what I was saying earlier, right? This is the same as saying 3 squared to the power 1 over x. Okay, is equal to 3 to the 5. Now how do I deal with this? I just multiply it out, right? So 3 to the power 2 over x equals 3 to the 5th power. Now if I have the same base on either side, I can get rid of the bases and just equate the exponents. Okay, so this will become 2 over x equals to 5. Okay, and then it's a simple case of isolating x and solving for it. So therefore x is equal to 2 over 5. Okay, and again, take this answer, substitute it in here, and see if you get the correct answer. And if you do, that means your answer is correct. Okay. Let's move on to question 2.3. It says simplify the following fully. Okay, it's a very ugly looking expression, but let's deal with it. So we have p squared minus q squared times p plus q to the power 5 over 2 all over p minus q to the power 1 over 2. Okay, now let's start by looking at this. Okay, if you look at that, that should immediately remind you of difference of two squares. Okay, so root and then p plus q, p minus q. Okay, and then this whole thing multiplies by p plus q to the power 5 over 2. Okay, and then the bottom one, if you look at half, remember I was explaining on top here, that's the same as the root of that. Okay, so this is the same as saying the root of p minus q. Okay, so let's see now. When it comes to two brackets being multiplied under a square, I can just isolate them. Okay, so I can say p plus q times the root of p minus q. Okay, so I just took this and I broke it down into these two parts. Okay, and this remain the same, so I'll just bring that down. P plus q to the power 5 over 2. Okay, and at the bottom we had the root of p minus q. Now if you look at this whole thing, the root of p minus q and here the root of p minus q, those are common, so I can just cancel it out. And then I'll have p plus q to the power of a half times p plus q to the power of 5 over 2. Okay, so I just took the square root and I made it half and I brought that down. Now we have a common base and we're multiplying two exponents, so I just add the exponents together, right? So I'll have p plus q to the power, and I'll just use my calculator now, 1 over 2 plus 5 over 2 gives us 3. Okay, so that's the final answer. Okay, let's now look at question 3. So 3.1 is a linear pattern. Okay, 7, 2, minus 3, and 3.1.1 says determine the general term. So the first thing is, let's see what the common difference is. So 7 minus, or 2 minus 7 is minus 5, and then minus 3 minus 2 is minus 5. Okay, so Tn is equal to, and then you write down the common difference times n, and then you see what the constant value is going to be. Okay, so let's test it. So minus 5 times 1 is obviously minus 5. So to get from minus 5 to 7, I have to plus 12. Okay, so let's test that out now. Minus 5 times 1 plus 12 is 7. Minus 5 times 2 plus 12 is 2. Minus 5 times 3 plus 12 is minus 3. So that works. Okay, so that's our general term. Okay, 3.1.2, calculate the value of t20. Okay, so now we have the general term. That's easy. You just substitute in 20 wherever you see n. Okay, so minus 5 times 20 plus 12 gives us minus 88. Okay, 3.1.3, which term in the pattern has a value of minus 138? Okay, so in 3.1.2, we were given the term and we had to find the value of the term. In 3.1.3, we're given the value of the term and we have to find out what term number that is. Okay, so Tn is equal to minus 5n plus 12, and we're given the value of Tn. So let's just substitute that in. So it's minus 138. And now it's a simple case of just solving for n. So I'll minus 12 on that side and then divide everything by minus 5. So minus 138 minus 12 gives us minus 150. Divide by minus 5 is 30. Okay, let us now look at 3.2. 3.2 says 6, 2x plus 1 and 3x minus 3 are the first three terms of a linear pattern. Calculate the value of x. Okay, so a feature of linear patterns is that they have a common difference. Okay, so that means if I take t3 minus t2, it'll give me the same answer as if I take t2 minus t1. Okay, so let's apply that logic here. t3 minus t2 is the same as t2 minus t1. So t3 minus t2, so 3x minus 3 minus 3x minus 3, this was t3, this is t2, and that's t1. Okay, so t2 was 2x plus 1. Okay, and then now t2 minus t1, so 2x plus 1 minus 6. Okay, now let's just expand everything and solve. Okay, so I'm going to keep all the x's on this side. We're going to group like terms. Okay, so I'm going to bring this over to this side. So I'll have minus 2x here. And then I'll take all of these to the other side. Okay, so I'll have 1 plus 1 minus 6 plus 1 plus 3. Okay, so here I'll have 3 minus 2 is minus 1, so minus x. And then 1 minus 6 plus 1 plus 3 gives us minus 1. Okay, so therefore x equals 1 because I divide both sides by minus 1. Okay, let's move on to question 4. Okay, let's now look at question 4. So question 4 is a continuation of number patterns, and this is a quadratic pattern. Okay, so the quadratic number pattern 4p11q22 has a constant second difference of 1. Show that p equals 7 and q equals 16. So let's start by writing this down. 4p11q22. Okay, so let's do this. Okay, and now I'm gonna have some number here. I'm gonna have some number here. I'm gonna have some number here, which is the difference of these, and some number there, right? And our constant second difference is 1. Okay, so let's think now. 4, sorry, this has to be p minus 4, right? Because it's the difference between those two. And this is 11 minus p. Okay, and this is q minus 11. Okay, and this is 22 minus q. Okay, and when we subtract all of those, we should get 1. Okay, so if I take 11 minus p minus 4, okay, so I took this, and I subtracted it by that, right? I'm gonna get 1. And when I do that for the other two, so I say 22 minus q minus 11, I must also get 1. So let's solve for these now. Okay, so 11 minus p plus 4 equals 1. So minus 2p equals 2, and I'll just bring those to the other side. Okay, so 1 minus 11 minus 4 gives us minus 14. So therefore p equals to 7 because I divide by minus 2. Okay, and for q, let's do the same thing. So 22 minus q plus 11 equals 1. Okay, so minus 2q equals to 1 minus 11 minus 22 gives us minus 32. Okay, and now I'll divide both sides by minus 2, and that gives us 16. Okay, so p is 7 and q is 16. So that means these answers are correct. Okay, that's 4.1. Let's now look at 4.2. So 4.2 says determine the general term of the quadratic pattern. Okay, so I'm just going to shift this over a bit, and now I'm gonna edit this a bit so that we get actual numbers in here. Okay, so in place of p, I'm gonna say 7. So 7 minus 4 is 3. Okay, and here we had 7, and here we had 16. Okay, and then 11 minus 7 is 4. Okay, and then 16 minus 11 is 5. Okay, and then 22 minus 16 is 6. Okay, now how do we find the Tn, so the general pattern, the general term, sorry, of the quadratic pattern? So we can say that 2a is equal to 1. Okay, and 3a plus b. Okay, so 3a plus b equals to 3, and a plus b plus c equals to 4. Okay, cool. So a equals to a half, right? Now I can take that half, substitute it in here. Okay, so 3 times half is obviously 3 over 2, and then 3 minus 3 over 2 is 3 over 2. Okay, and then I can take a and b now and substitute it in here to get c. Okay, so c equals to, let's see, so 3 over 2 plus 1 over 2. Okay, and then 4 minus that is 2. Okay, now we can write this. So Tn is equal to an squared plus bn plus c, and now I can just sub in the values that I calculated. Okay, and again, you should always test the answer that you get. Okay, so let's take this. Let's try it with the pattern that we have over here, right? So I'll say in my calculator now 1 over 2n. So in place of n, I'll put 1 squared plus 3 over 2n. Now instead of n, I'll say 1 plus 2. And the answer I get is 4. Okay. And now wherever I put in 1 in my calculator, I'll put in 2. So now I'll have half times 2 squared plus 3 over 2 times 2 plus 2. And that gives me 7. And then if I do this with the rest, so I'll just try one more now. So if we put in 3, I should get 11. Okay, so that means our answer is correct. So you should always test your answers to make sure that they're right. Now that we have that there, we can simply do this one. Okay, so determine the value of n if Tn is equal to 232. Okay, so this is 4.3. So 232 equals to half n squared plus 3 over 2n plus 2. Okay, let's bring all of our things over to one side. So I'll have 2 minus 232, which is obviously minus 230, right, equals to 0. Okay, and now I can just use the quadratic equation. So minus b plus minus the root of b squared minus 4ac all over 2a, right? And when I punch that, so I'll first put it in my calculator with plus and then with minus, and I'll get two answers, right? So let's do it. So minus b, so in place of b, I'm going to put 3 over 2 plus the root of b squared, so 3 over 2 squared minus 4a is half c minus 230 all over 2a. So instead of a, I'll say half. Okay, if I press equals, I'll get 20. Or n is equal to Now I'll go on my calculator, and where I had plus here, I'll put in minus. Okay, and that gives me negative 23. Okay, now think about this here, right? Can I have a negative term? No, so that means the answer is 20. Okay, and then I say this is not equal to that. Okay, let's look at 4.4. Okay, so it's a continuation of this, right? If the sum of two consecutive terms in the pattern is 1227, calculate the difference between these two terms. Okay, so the sum of two consecutive terms, right? So let's think about this. Tn plus Tn plus 1. Okay, what does that mean? Let's say, for argument's sake, this is T5 we're talking about. Okay, and let's just make up a number. Let's say at T5 the value is 30, right? And at T6 the value is 31 or 40, right? That means the sum of two consecutive terms in this example would be 70, right? Because I just add those two. So this is Tn and this is Tn plus 1. Okay, so in this case we're told that Tn plus 1 gives us 1227. Okay, now we have equations for this here. We know what Tn is. We calculated it here. Okay, so in place of Tn, I'll put in my equation, which was half n squared plus 3 over 2n plus 2. Okay, so that's for Tn. Right, now I'm adding all of that to Tn plus 1. Okay, so now in place of n, I'll put n plus 1. Okay, so all of this is for that. Okay, so now let's expand everything and solve for n. Okay, so half n squared plus 3 over 2n plus 2 plus half. Now it's square binomials. Okay, so it's n squared plus 2 times n, right? Because remember you multiply these two, so you'll get n times 1, which is n, and then you double it, so 2n, and then you square the last term. Okay, plus 3 over 2n plus 3 over 2, right? Just multiply it into the brackets, plus 2, and then I'll bring this to the other side, minus 1227 equals 0. Okay, let's do this one more time. Let's just go through and open up these brackets. Okay, and you should be very careful not to make any errors, because it'll make the whole question, the whole answer wrong. Okay, now I'll group like terms. So let's find all the n squareds. Okay, I think that's the only two. So half plus half is 1, so we just have n squared. Now let's find n. So here's n, here's n. Okay, so I think it's just those two. Okay, so 1 plus 3 over 2 is 5 over 2. Okay, and now let's find all the ones without variables. Okay, and oof, lucky I got this, and I'm just looking now, this is supposed to be 3 over 2n. Okay, so this should actually be, this is also n. Okay, so that should actually be 3 over 2 plus n, so plus 1, plus 3 over 2. Okay, so this is 4n. Okay, and then now we can add all the uns, the ones without any variables, the constants. Okay, so let's do that quickly. So we have 2 plus 1 over 2 plus 3 over 2 plus 2 minus 1227. Okay, and that gives us minus 1221. Okay, and equals to 0. So now let's use the quadratic equation. So minus b plus or minus the root of b squared minus 4ac all over 2a. Okay, and again now I'm just gonna put this into my calculator, and then one time do it with plus and then the second time with minus. Okay, so minus b, so it will be minus 4, right, because this is b, plus the root of b squared, so 4 squared is 16, minus 4a, a is just 1, and then c is minus 1221. Okay, all over 2a, so 2 times 1, and that gives us 33, or n is equal to, and now in place of plus I'll put minus 37. Okay, again we can only have a positive thing, so this is the right answer and this is not right. Okay, but now let's read the question. What did the question actually ask for? It said the sum of the two consecutive terms is 1227. Okay, so we found where those two terms are, right? We now know the value of n. We know that n is 33. So that means if you take t33 plus t34, because that's the next term, two consecutive terms, we're getting 1227. Okay, but now they're telling us to find the difference between those two terms, right? So now if we have the value of the we know which term it is, we can easily just subtract. So now we're going to say t34 minus t33. Okay, and now it's just a case of saying half 34 squared, where's our thing, half n squared plus 3 over 2, so plus 3 over 2n plus 2 minus, now this the whole thing gets subtracted, right? So half times 33 squared plus 3 over 2 times 33 plus 2. Okay, so let's see, that gives us half 34 squared plus 3 over 2 times 34 is 51 plus 2. I'm just going to add this 2 straight away. Okay, so this will become 53 minus half 33 squared minus, now 3 over 2 times 33 is 99 over 2 minus 2. Okay, so I just multiply this negative sign by each of those. Okay, and now I'll just put all of this into my calculator and get an answer. So half times 34 squared plus 53 minus 1 over 2 times 33 squared minus 99 over 2 minus 2. Okay, and that gives us a final answer of 35. And that answer is correct. Okay, let's now look at question 5, which is the start of the functions questions. Okay, so question 5 says, given f of x is equal to 4 over x minus 3 plus 2 and g of x equals to x plus 2, write down the equations of the asymptote of f. Okay, so what are asymptotes? Remember, asymptotes are basically lines that your graph will get really close to. It'll approach, but it won't touch. Okay, so let's look at this here. So for hyperbolic graphs, which f of x is, there's a vertical and there's a horizontal asymptote. Okay, so the vertical asymptote is going to be x equals to 3. Okay, and then the horizontal will be y equals to 2. Okay, and we'll see how that works when we sketch the graph here in 5.4. Okay, but for now, just know that you take this becomes the y asymptote, and then this becomes the x asymptote. So you take whatever that is and you negate it. So if it is plus 3, it will become minus 3. Okay. Let's look at 5.2 now. So 5.2 says determine the x-intercept of f. Okay, so remember x-intercept y equals to 0. Okay, so let's just equate this whole thing to 0. So 4 over x minus 3 plus 2. Okay, we just take in the equation of f of x. Okay, now we can just solve for x. So I'll bring this to the other side. So I'll have minus 2. And now I'll multiply everything by x minus 3. X minus 3 equals to 4. Okay, so I basically just brought that to that side. Multiply this through everything so that it becomes 4 on its own. Okay, let's multiply out of these brackets. So minus 2x plus 6 equals to 4. I'll bring this to that side. So 4 minus 6. 4 minus 6 is minus 2. And then therefore x is equal to 1. Okay. So that's the x-intercepts of x. So it's the actual coordinates are 1 and 0. Okay. 5.3 determine the y-intercept of f. Okay, so 5.3 now it's the opposite. So y-intercept x equals to 0. Okay, so y equals to 4 over x, and now instead of x I'm going to put 0 minus 3 plus 2. Okay, so this just becomes 4 negative 4 over 3 plus 2. I'm going to put that in my calculator. Negative 4 over 3 plus 2, that gives us 2 over 3. Okay, so then the actual coordinate is 0 and 2 over 3. Okay, let's look at 5.4 now. It says sketch the graphs of f and g on the same system of axes. Show clearly all the intercepts with the axes and any asymptotes. Okay, so let's first draw our set of axes. Okay, there's that. And now the next thing to do is the asymptotes. Okay, so we have our equations of our asymptotes over here. So we'll just draw that in now. I'll use blue. And so y equals 2. So here's y equals 2. It's going to be somewhere above the x-axis. And then x equals to 3. So x equals 3 is going to be somewhere on the right or on the left, sorry. On the right of the y-axis. Okay, so that will be there. Okay, and now we can just sketch in our graph. So let's draw in f of x in red, and remember f of x is our hyperbolic graph. Now there's a few things to take note of. Okay, so we took care of the asymptotes, right? Now we need to take care of the shape. So the general equation for a hyperbolic graph is y equals to a over x minus b plus q, right? Now we've dealt with this q and p, right? That's the asymptotes. Okay, let's talk about this a now. So when a is positive, right, when a is positive, like in this case here, then our hyperbolic graph lies in the first and third quadrants. Okay, and when a is negative, it lies in the second and fourth. Okay, so keep that in mind. And now let's look at this one here. So in this case, a is positive, right? It's plus 4. Okay, so that means our graph is going to be in the first and third. Okay, so let's draw that in now. And remember, they won't touch the asymptote, so we'll use these blue lines that we drew as guides. Okay, so let's just extend this a bit. Okay, and now the first quadrant is here, right? So now light will move up to here basically. Okay, so let's put that in. And the third quadrant, so down here. Okay, let's draw it a bit neater. And you can see that it's not touching those asymptote lines. Okay, now let's put in these intercepts that we had. So the x-intercept was at 1 and 0. So the x-intercept is at 1 and 0. And our y-intercept was at 0 and 2 over 3. So 0 and 2 over 3. Okay, so that takes care of f of x. Okay, now let's do g of x. So I'll do that in red. G of x is just a straight line, x plus 2y equals x plus 2. Okay, so what does that mean? That means that we had a straight line and then it got shifted up by 2 units. Okay, so we started off here with y equals x and it moved up by 2 units. So let's do that. So we'll take the straight line and just move it up to 2 units. Okay. Now, another thing that you should keep in mind is you might just label these asymptotes. So this was y equals 2, and this one was x equals 3. Okay, and let's put in this point here as well for the y-intercept of this. It's just 0 and 2. Okay, and how did I get 2? Because that's the shift there. Okay. Okay, so now that we have this drawn, I think that's all the information they asked for. They asked for the intercepts, which we've shown, and the asymptotes. Okay, let's now look at the next question. 5.5. Calculate the x coordinates of the points of intersection of f and g. Okay, so you can see we have 2 points of intersection. So let's find what those x values are. So the way to do that is just to take f of x and equate it to g of x. Okay, so let's do that. 5.5 f of x equals to g of x, right? So we have 4 over x minus 3 plus 2. 4 over x minus 3 plus 2 equals to x plus 2. Okay, x plus 2. Now if you look at these plus 2's, if I bring this to this side, it's going to become minus 2. So it'll just cancel each other out. So I can get rid of those already. Okay. And then now I can get rid of this fraction by multiplying it. So this will become x times x minus 3. Alright, you can see I brought this from here to there. Okay, so 4 equals x squared minus 3x. And now I'll just bring this 4 to this side. So this will become minus 4. And this will become 0. Okay, and now you can see we just have a quadratic equation to solve, and that makes sense. We'll have 2 x values because we have 2 points of intersection. Okay, so let's quickly solve that. Now remember, to solve this trinomial, to factorize it, we need to find 2 numbers that when I add them together I get minus 3, and when I multiply them together I get minus 4. So let's see what those 2 numbers are going to be. Okay, let's try minus 4x plus x. Okay, so this is the same as saying plus 1x minus 4. Let's see if that works. So if I take minus 4 plus 1, I get minus 3. If I take minus 4 times 1, I get minus 4. So that gives me my minus 3 when I add them together, and that gives me my minus 4 when I multiply them. Okay. Okay, cool. So now it's just a case of factorizing all this here. Okay, and remember this was equal to 0, this was equal to 0. Okay, now I can take out this common factor x minus 4. So x minus 4, x plus 1 equals 0. I can equate them both to 0, so I'll get x equals 4 or x equals to minus 1. Okay, so that's our final answers, and that's correct. Now let's go back to our graph and see if that makes sense. So here x equals minus 1. That makes sense, it's before the y-axis. And x equals to 4. And that makes sense for here. Because remember, this line is minus 3. Oh, sorry, this line is 3. So this makes sense if that's 4. It's after that. Okay, cool. Okay, so that takes care of 5.5. Let's look at 5.6. If x is less than 3, determine the values of x for which 4 over x plus 2 is less than x plus 2. Okay, so if we look carefully now, 4 over x minus 3 plus 2 and x plus 2 is literally just f and g, right? Those are the same exact equations. Okay, so the question is basically asking, let's write this in a way that makes more sense. For which values of x, let's ignore this first part for now, let's just read this. For which values of x will f of x be less than g of x? Okay, so you can take a roll this and just ask the question as it is, right? But now they're saying let's restrict that question to when x is less than 3. So if we come back to our graph here on top, we're talking about all the values less than 3. Okay, so there's x equals 3. So we're going to consider everything before that. Okay, because they want less than 3. So if we look at our graph here, okay, right, they're asking for the values of x where f of x is less than g of x. Okay, so f of x is our parabola, and it is less than the straight line than g of x from this point onwards, right? You can see that if we start from here going in this direction, it's greater, right? You can see it's above the straight line. If we keep going, it's always above until that point of intersection, and from there till our asymptote, it's less than the straight line. So that's basically the area that we're looking for. Okay, so from here till there. And our x value here, remember, was -1. Okay, so our answer then will be, so for 5.6, our answer will be that x has to be greater than -1 but less than 3. Okay, see if that makes sense. So I'm going to highlight the part that we're talking about. We're talking about from here until the asymptote, right? And you can see from that point onwards, our straight line is actually greater than our hyperbolic graph. So that means that answer is correct. Okay, let's move on to the last question now. 5.7 says the line y equals to x minus 1 cuts f, so that's our hyperbola, at P, which has the coordinates of 1 and 0, and Q. Write down the coordinates of Q. Okay, so let's think about this. The line y equals x minus 1. Okay, so here's a line y equals x. Okay, there's a cut in the origin, and then I moved it down by 1. Okay, so question is, at what points do they intersect? So we told that it intersects at 1 and 0. Okay, so here's 1 and 0 actually already drawn on, which was the x-intercept. So this point is point P then, and then we have to find point Q. Okay, so let's do that. So again, we're just going to equate f of x to that line y equals x minus 1. So our equation for f of x was 4 over x minus 3 plus 2 equals to x minus 1. Okay, so let's get rid of this denominator by multiplying it out. So I'll have 4 plus 2 times x minus 3 equals to x times x minus 3 minus 1 times x minus 3. Okay, so I'll have 4 plus 2x minus 6 equals to x squared minus 3x minus x plus 3. Okay, let's put all our terms on one side and group them. So I'll have x squared. Now I'm going to bring this minus 2x to this side and then add all our terms with x. So minus 3 minus 1 minus 2. Okay, because I brought this minus 2 to that side. So that becomes minus 6x. And now I'll do the same with our terms without any variables. Okay, so I'll take this first 3 on this side. So 3 plus 6 minus 4 gives us plus 5 equals to 0. Okay, and now it's a case of just finding our factors and then solving. Okay, so again, we're going to look for two numbers that when I add them together, I get -6, and when I multiply them, I get +5. So x squared, let's try -5x minus x, right? -1x, same thing, +5 equals 0. So if I take -5 minus 1, I get -6. If I take -5 times -1, I get 5. So there's our -6, okay, and there's our +5. So that means that that works. Okay, so now that we have our factors, let's factorize. So I'll have x minus 5 minus 1 times x minus 5. Okay, I have common factor here, so I can factorize that out. X minus 5, x minus 1 equals 0. I'll equate them both to 0. I'll have x equals 5 or x equals to 1. Now, we can very easily confirm that this answer is right because x equals 1 and we were told that one of the points of intersection is when x equals 1. Okay, so that's obviously for the point P. That's for the point P. And then we have to find the point Q. So that means that the x value of Q is 5. Okay, so let's just take this out. And then we can say, therefore, x of Q is 5. Okay, and then we can just use that equation that they gave us, y equals x minus 1, to find the y value. Okay, so y equals to 5 minus 1. So that means that y equals to 4. Okay, let's write it down. 5 minus 1, and then therefore y equals to 4. Okay, so that means that the point Q is at 5 and at 4. Okay, now let's think if that makes sense. Okay, so we're saying that Q is at 5 and 4. Right, let's go back to our graph where we drew it in. Remember, this was the line y equals 2. So the fact that our point of intersection is above that there, right? We said this is at 5 and 4. Okay, so the fact that this is at 4 means that that looks fine because it's above that line. And the fact that this is 5 and this line here was 3 and it's on that side of the line means that that also makes sense. Okay, so that's question 5 done. Okay, we're now looking at question 6, which is a continuation of functions. So the question says, the diagram below shows the graph of f of x, which is equal to minus into brackets x minus 3 all squared plus 25. Okay, so that's our parabola here. And g of x, which is 2 times 1/2 all to the power of x plus 1 minus 4. Okay, that's our exponential graph there. And then we told that graph f cuts the x-axis at point A and C, and the y-axis at point E, and has a turning point at T. Okay, and graph G cuts the x-axis at A as well, and the y-axis at B. Okay, so now we have all the information. Let's read the questions and answer them. 6.1, write down the equation of the asymptote of G. Okay, so G is our exponential graph, and our asymptote, they even marked it here for us, is going to be, let's look at this here again, it's going to be our shift. Okay, so minus 4. So our asymptote is y equals to minus 4. Okay. 6.2, write down the coordinates of D. Okay, so D is our turning point of the parabola, which was f of x. Now, before we continue, let's just talk about parabolas, right? There's 3 different ways that you'll see the parabola function given. Okay, so you first have standard form, right? A of x plus b of x plus c. And this is y equals to that. Okay, or you can have the x-intercept form, so you have y is equal to a x minus b x minus q, or you can have y is equal to a x minus b squared plus q. Okay, this is called turning point form. Okay, this was the x-intercept form, and this is our standard. Okay, so what are we given? We're given the turning point form, right? If you look at this, That's the turning point form. Okay, and what? So let's get rid of this for now then. What do these things represent? Okay, so our P is the turning point. P is the X value of the turning point. Okay, and Q is the Y value of the turning point. Okay, so now let's look at the question again. We are asked to find the coordinates of the turning point D. So that means it's going to be 3, right, and 25. Okay, and if we look at our graph, that makes sense. 3 is that side of the y-axis and 25 is high above the x-axis. Okay, so let's just write this in. 3 and 25. Okay, write down the range of f. Okay, what is a range? Range is our y values. So if you look at f, it has a maximum point, right? Concave down parabolas have maximum points, whereas concave up parabolas have minimum points. Okay, there's our max, there's our min, and it's the turning point of the graph. Okay, so if you look here, our maximum point is 25, right? You can't go higher than 25, but there's no limit down. You can go infinite. This will carry on to infinity. This will carry on to infinity. Okay, so that means that our range is that y is less than or equal to 25. Okay, because it can equal to 25. That is our turning point, but it can't be greater than that. So it's less than or equal to 25. Okay, 6.4. Calculate the length of EB. Okay, here's EB here. Right. So what are we going to need to find this here? Well, from the looks of it, this is on a straight line, right? EB is lying on the y-axis. So we just need to find what the y value is here and what the y value is here. So we'll call this y1, y2, and then we can just find the distance between them by subtracting that. So let's find those two y values, okay? So point E represents the y-intercept of f of x, while B represents the y-intercept of g of x. Okay, so basically all this question is asking you is to find the two y-intercepts. Okay, so 6.4 y-intercept x equals 0. Okay, let's start with f of x. So minus x minus 3 squared plus 25. So y is equal to minus x minus 3 squared plus 25. Okay, yep. So if we said x-intercept y is equal to 0, we're going to now replace this x with 0. So y is equal to minus, and then 0 minus 3 is just minus 3 squared plus 25. Okay, so that's going to be minus 9 plus 25. So minus 9 plus 25 is 16. Okay, so that means that this point, this was E, is at 0 and 16. Okay, so let's put that in. So therefore E is 0 and 16. Now before we carry on, let's just see if our answer makes sense. Remember we said our height here was at 25. So it makes sense for this to be at 16 because it's below that point. Okay, so you should always test your answers and see if they make sense. Okay, let's now find the y-intercept of the exponential. Okay, so 2 times y is equal to, let's make that meter, y is equal to 2 times 1/2 to the power x plus 1 minus 4. X plus 1 minus 4. Okay. So now in place of x, I'm going to put 0. So 0 plus 1 is just 1. And you can take the 1 away because it's the same thing, right? So the 2 times half is 1. 1 minus 4 is minus 3. Okay. So therefore, B is at 0 and minus 3. Okay, and again that makes sense because it's above our minus 4 line here. Okay, so this is 0 and minus 3. Another thing to keep in mind is that with exponential graphs, the y-intercept will always lie exactly 1 unit above the asymptote. Okay, so then in this case, this was at -4. So this lies at -3. Okay, so we didn't even need to do a calculation. You can just state that. But if you're unsure, you can just calculate it and you'll get the right answer. Okay. So now let's see, the question actually asks for the length. So all you have to do is subtract it. So therefore, EB is equal to 16 minus -3, which is 19 units. Okay. Okay, cool. Let's look at 6.5 now. Determine the values of x for which f is decreasing. Okay, so if you look at f, that's our parabola. I'm just going to get rid of this for now. If we look at our parabola, we have 3 points that it can basically be, right? It's either increasing, decreasing, or stationary. So at our turning point, our graph is always stationary. Okay. And with this downwards facing parabola, everything before that point, so everything up until that point, the graph is increasing. Okay. And everything after that point, the graph is decreasing. Okay, so this is the decreasing part. Okay, decreasing, and this is the increasing part. So the question is saying determine the values of x for which it's decreasing. Okay, so it's decreasing whenever x is greater than 3, right? Because it's moving in this direction then. Okay, so that's our answer then. When x is greater than 3. Okay, let's now look at 6.6. It says calculate the average gradient between points A and B. Okay, so point A is the x-intercept of f of x, right? And point B is the y-intercept of the exponential graph, and we already found that coordinates. It was 0 and -3. Okay, so our job is now to just find A. Okay, so let's do that. So x-intercept y equals to 0. Okay, and our equation is minus x minus 3 squared plus 25. Okay, so 0, or let's start here, y is equal to minus x minus 3 squared plus 25. Okay, now I want it where y is equal to 0, so I'll just replace that. Okay, and now let's solve. Okay, so I'll bring minus 25 on this side, and we have minus x minus 3 squared. Okay, let's get rid of these two negatives, so I'll divide both sides by -1. Okay, let's find the square root of 25. Now remember, this can be plus or minus 5. Okay, so x minus 3 is equal to plus 5, or x minus 3 is equal to minus 5. Okay, so that means x is either equal to 8, right, if I bring that to that side, or x is equal to minus 2. Okay, so this is obviously, so a is going to be at minus 2 then, right, because it's on this side of the y-axis, and then this is going to be at 8 and 0. Okay, so we can state that therefore a is at minus 2 and 0. Okay, and we already knew b was at 0 and minus 3, right? And the question says the average gradient between that. So the gradient of AB is equal to change in y over change in x, right? So let's take our two y values, minus 3 minus 0 over, and now let's look at our two x values, over 0 minus 2. Okay, and that gives us minus 3 over 2. Okay, so that's our final answer then. That's our average gradient. Okay. 6.7 says graph T is obtained by reflecting G. G is our exponential graph about the x-axis. Write down the range of T. Okay, again, range is our y values. Okay, so we took graph G, which was our exponential graph over here, right? And we reflected it, about this x-axis, right? So how is that going to look now? So you can imagine that if I took this point and I moved it here, let's say, right? Because I reflected it there. And then I took this point here and I moved it there, right? And then I took this point and I moved it there. So you can see it's all getting reflected. Now let's draw out that line, how that's going to look. It's going to look something like that, right? So our asymptote now goes there. So where initially it was -4, now it's going to be +4. Okay, so our range then is that x is less than 4. Okay, so to write down the range of t, the range of t is that y is less than 4. Okay, cool. And let's just write down what the graph of what t of x actually is. So t of x is equal to, so it's the exact same part. The first part is exactly the same, right? 2 times 1 over 2x plus 1. But now instead of saying -4, we're going to say +4. Okay, so that's how we got to that point there. Okay, 6.8. If p equals to f of x plus 2, write down the coordinates of the turning point of p. Okay, so let's think about this now. 6.8. F of x was minus y is equal to minus x minus 3 squared plus 25, right? Now if I add 2 to that, right? If I add 2 to that, to f of x, I'll get plus 27. Okay, so I just took 25 plus 2, that's 27. Now remember what I was saying earlier about this being the turning point coordinates, right? So the new turning point now is going to be at 3 and 27. Okay, 6.9, determine the value of k for which the straight line y equals to 2x plus k will be a tangent to f. So remember, a tangent is just any point, any line that cuts the graph at exactly one point. Okay, so it does touch the graph, but only at one point. So that means at some point they are equal to each other. So we can start off by equating f of x to that line there, right? So what is f of x? F of x is minus x minus 3 squared plus 25. Okay, equals to, and now we equate it to that, 2x plus k. 2x plus k. Okay, let's square our binomial here. So x squared minus 6x, because I multiply them, so that gives me minus 3x, and then I double it, so minus 6x plus 9 plus 25, and then I'll bring these terms to this side. So minus 2x minus k equals 0. Okay, so this gives me minus x squared plus 6x minus 9 plus 25 minus 2x minus k equals 0. Let me group my like terms and add them. So plus 6 minus 2 is plus 4x, and then minus 9 plus 25 is plus 16, and then minus k doesn't have any other terms, right? So what do we have here now? Here we have a quadratic equation, right? And how do we find so if we want to find the points where the two graphs are touching, remember the roots are going to be equal at that point, okay, because they only touch at one point. So that means both, if you take a normal parabola, right, let's say I take this parabola and I draw any other line, let's say like that, right, I'll find 2 points of intersection, okay? But with a tangent, I only have 1 point of intersection, okay? So that means that the roots, because there has to be two roots, will be at the exact same point. Okay, so there's equal roots. Okay, so to do that, to get equal roots, we have to equate our roots to 0. So delta b squared minus 4ac, that's how you find the roots, the nature of the roots. So if we equate this to 0 now, that's where we'll find the point where we have equal roots. Okay, so b squared, so 4 squared minus 4a is minus 1. And then c is this entire term here, two terms, okay, 16 minus k equals to 0. Okay, 16, because I just squared 4, plus 4 times 16 minus k equals 0. Okay, so 16, 4 times 16 is 64, so plus 64 minus 4k equals 0. Okay, 16 plus 64 now is 80, so 80 equals to 4k. Alright, I just moved this to that side. So therefore k is equal to 80 divided by 4, which is 20. Okay, so that's the answer then. Okay, let's now look at question 7, which is finance. Okay, let's start 7.1. It says calculate the effective interest rate per annum if an investment earns an interest at a rate of 11.5% per annum compounded monthly. Okay, so what is effective interest? Effective interest is basically if there was no compounding, right? How much would I actually have to charge the interest at? Okay, so 11.5% per annum is when it's compounded monthly. Now, if I wasn't compounding it, what interest rate would I have to charge to get to the same total amount of interest? Okay, that's what effective interest is. Now, to calculate that, there's a formula. So it's 1 plus I effective equals to 1 plus the I nominal. Okay, so that this is the nominal interest, this if you are compounding. Okay, over the time to the power of the time. Okay, so 1 plus, and now we're solving for the effective. 1 plus the nominal is 11.5%, so that's 0.115. Okay, I just took 11.5 divided by 100, and then you get 0.115 over, now how many months are there? We're compounding it monthly. Okay, so if we're looking per annum, that's 12 months. Okay, so 12 and 12. Okay, and now it's just a simple case of solving for I effective. Okay, so I'll put this entire thing into my calculator. I'll get an answer and then I'll subtract it by 1. Okay, so let's do that. So on my calculator now, 1 plus 0.115 over 12 all to the power of 12. Okay, and then I'll subtract 1 from that answer, and I get 0.1213. Okay, and that's the same as if I multiply it by 100, that gives me 12.13%. Okay, let's look at 7.2 now. 7.2 says Karabo bought a computer for 4,700 Rand. The value of the computer depreciated at a rate of 18% per annum using the reducing balance method. Okay, calculate the book value of the computer after it was bought. Okay, so with depreciation, there's the straight line method and there's the reducing balance. So reducing balance you can think of as the reverse of compound interest. Okay, so you'll see the formula looks almost identical. Okay, let's just write it down. A equals to P1. Now in compound interest we have a plus here. Okay, so for reducing balance depreciation we have a minus. So minus I to the power of n. Okay, so let's see what the question says. Calculate the book value. Okay, so in all these things, A represents the current value of the thing and P is the initial value. Okay, so we're solving for A in this case, and P is our initial value, which was 4,700. So 4,700 times 1 minus, and then the depreciation rate was 18% per annum. Okay, so that's 0.18 to the power of n. Right, how many years was it? 4 years. Okay, so 4. Okay, and I'll just plug all this into my calculator. So 4,700 times 1 minus 0.18 all to the power of 4, and that gives me 2,124.97. Okay, so that's the current value. So you see, it started it being worth 4,700, and then after 4 years it's now worth 2,124 rand and 97 cents. Okay, 7.3, let's do it here. This person made an initial deposit of 20,000 rand into an investment account that paid an interest rate of 7.2% per annum, compounded quarterly. Okay, so that's 4 times per year. After 2 years, the interest rate changed to 7.8% per annum, compounded monthly. 4 years after his initial deposit, he withdrew 2,500 from his investment. Calculate how much he had invested in this investment account 2 years after the initial deposit was made. Okay, so 2 years after the initial deposit. So there's a lot of things happening here. Let's try to break it down. So initially there was 20,000 rand in the account, right? And it was compounded quarterly at that rate. After 2 years, okay, so after 2 years, so we can ignore all of this for now because in the first question is only asking for the first 2 years. Okay, so 7.3.1 A is equal to P1 plus I to the power of n, right? So A and the principal amount, so the starting amount was 20,000. Okay, 1 plus. Now remember, for the interest rate, it was compounded. So we have to take 7.2. Okay, so 7.2% the same as 0.072 over, and it's compounded quarterly, so 4 times a year, right? Over 4 to the power of. Now let's think about it. Okay, if there was no compounding, we were just looking per annum, we would put 2 years, right? But remember, we need to calculate interest 4 times a year because it's compounded quarterly. So 2 times 4 is 8, right? So it's 2 years happening 4 times a year. Okay, so that means the total is 2 times 4, which is 8. Okay, I'll plug all this into my calculator now and see what it gets. So 20,000 times 1 plus 0.072 over 4 all to the power of 8. And that gives me 23,068 rands and 12 cents. Okay, so that's how much it's worth after 2 years. How much will the investment be worth 7 years after the initial deposit? Okay, so 7 years after, let's see now. So now we looked at it until this point, until here. Okay, so now we can ignore this first part because we already know how much it's worth after 2 years. Okay. After 2 years, the interest rate changed to 7.8% per annum compounded monthly. Okay. 4 years after his initial deposit, he withdrew 2,500 from his investment. Okay, so let's establish a timeline here. Okay, so at the start it was 20,000 rand, right? At the 2 year mark, so this is 2 years, it's now worth this amount here, 23. I'll just say 23, and then we know it's that amount. Okay. Okay, so it's this amount here after 2 years, right? Now, 4 years after his initial deposit, okay, so at year 4, he withdrew 2,500, okay? Okay. And we know that from this point onwards, from 2 years onwards, the interest rate was now, just this year, it changed to 7.8 compounded monthly. Okay, so now let's work all this out. So we're going to have to do this in 2 steps. Because of the withdrawal, we're going to have to do this in 2 steps. So we're initially going to find these 2 years from the 2nd year to the 4th year. Right? We're going to find from year to year. We're going to find an amount. We're going to get what it's worth at this point. We're going to take that amount, subtract the amount he withdrew. Okay, and then we can find a new amount from there till the 7th year, which is what they asked for. How much will it be worth after 7 years? Okay, so let's do those 2 calculations. So let's start with this. This is the easy one, right? Well, they're both easy. Let's see. Okay, A is equal to P1 plus I to the power of n. Okay. Now the principal amount, like I said, we started with this. So 23,068.12 times 1 plus. Now let's look again, right? The interest rate was 7.8% compounded monthly. So now it's 0.078 over 12 because it's monthly, right? And the time is, now remember, 2 years, and the interest is calculated 12 times a year because it's monthly. So 2 times 12, so that gives us 24. Okay, let's get rid of this for now. Now I'll plug all this into my calculator. So I'm going to use that same answer from before, 23,068 times 1 plus 0.078 over 12, all to the power of 24. And that gives me a value of 26,949.02. Okay. Now, so that's at this point here, right? Now, at that point, he withdrew 2,500. Okay. So my worth after at year 4, right? So therefore, at year 4 is this amount minus 2,500. So minus 2,500, that gives us 449.02. Okay. And right, so now I can put in my value at that point, right? So that's at year 4, it's now worth 24 ... Okay, so that's this value here. Okay, now we're going to look at this second part here. So from year 4 to year 7, so that's 3 years. Okay, I'm just going to do it over here. So A is equal to P1 plus I to the power of n. Okay, A is equal to, and our principal amount is now this. Okay, so 24,449.02, 1 plus I, and remember the interest rate hasn't changed, so this is still 0.078 over 12, and now it's for 3 years times 12. Okay, so 3 times 12 is 36. Okay, punch all of that into my calculator. So I'll use that same answer from before, 24,449 times 1 plus 0.078 over 12, all to the power of 36. And that gives me 30,871 rands and 48 cents. Okay. So that means that after 7 years, it's now worth 30,000 and something. Okay, so it's this point here. Okay, so let's recap what we did, right? So this guy invested 20,000 rand. Okay, so this is year 0. Okay, he invested 20,000. That's how much it's worth. Okay, that paid an interest of 7.2% compounded quarterly. Okay, so we can calculate the value at 2 years now, right? We did it here. Okay, this is the value at 2 years. So that's how much the account is now worth. Then after 2 years, the interest rate changed to 7.8% compounded monthly. Okay. So from this green line represents that. So from that point onwards, it's now 7.8% compounded monthly. 4 years after his initial deposit, so at year 4, he withdrew 2,500 rands. Okay. And then now we have to find what's worth after 7 years. Okay. So remember where we at now. We started at 20,000. We calculated how much it's worth after at the 2-year mark. Right. Now from this point onwards, we're doing basically 2 separate calculations because at some point at year 4 he withdrew some money. Okay. So from year 2 to year 4, that's 2 years, and we can calculate how much it grew by. So it grew from 23,000 and something to 26,000 and something, right? At that point, he decided to take out 2,500, okay? And that brought us to this value here. So now at the 4-year mark, it's actually worth 24 point something, okay? Then what happened? He didn't take anything out, nothing changed. The interest rate was still 7.8% compounded monthly. Okay. So at that point, all we had to do was just calculate for those last 3 years. And we used our principal amount as how much it was worth at that point. Okay. So it's not complicated. You just have to break down what's been asked and then answer it. Okay. Let's now look at question 8. So this is now probability, right? Let's read the question, see what it says. A bag contains 6 red balls, 8 green balls, and an unknown number of yellow balls. The probability of randomly choosing a green ball from the bag is 25%. Show that there are 32 balls in the bag. Okay? So how are we going to do that then? Well, the probability of choosing, what was it? Green. So probability of green is 25%. Okay, and what is the probability of green? Well, it's 8 over the total number. Okay, so 8 over, let's just call it t, equals to 0.25. Right, so now it's just a simple case of solving for t. So I'll multiply t to that side and then divide both sides by 0.25. Okay, so 8 divided by 0.25 is 32. So that means that there are 32 balls. So that answer is correct. Okay, 8.2. A ball is drawn from the bag. The color is recorded and it is not returned to the bag. Thereafter, another ball is drawn from the bag. The color is recorded and it is also not returned to the bag. Draw a tree diagram to represent all the possible ways in which the 2 balls could have been drawn from the bag. Show the probability associated with each branch as well as the outcomes. Okay, so let's think about this, right? When I initially start, I have 3 options, right? Well, there's 3 outcomes that could happen, let's say rather. I can either draw a red or green or yellow. Okay, so red, green or yellow. Okay, now the probability of drawing red is 6 over 32, right? Because there's 6 red balls and there's 32 in total. The probability of drawing green is 0.25, so it's 8 over 32, right? 8 over 32. Okay. And then the probability of drawing yellow is, let's calculate how many yellow balls there are. So we have 6 plus 8, which is the red and green, and that gives us 14. And then 32 minus 14 is 18, because there was an unknown number, but now we know that number is 18. Okay, so 18 over 32. Now, let's say you pick one of these. Now what's going to happen? Let's see. So let's say you pick red. Okay. In my next pick now, there's 3 things that can happen again. Right? I can either get red again, or green, or yellow. Okay. I'm just going to copy this and put it for the rest of those as well. So Okay. Now let's think about this. How did the probability change? Well, initially my probability for getting red was 6 over 32. But what happened? I picked a ball, right? And it wasn't returned to the bag. Okay, so if I picked red initially, now there's going to be one less red. So the probability of me getting red is now 5 over 31. Okay, because there's one ball less in the bag. Okay, my probability of getting green is still 8 because there's still 8 green balls, but now it's over 31. Okay, and then for yellow it's the same, 18 over 31. Okay, now let's say I picked green first. Okay, now my probability of getting red is still my initial probability of getting the initial number of red balls, which is 6. Okay, so 6 over 31. And then green, now it's 1 less, so now it's 7 over 31. My yellow, that hasn't changed, still 18 over 31. Now let's say I picked yellow first. So now there's still the same number of red balls, so it's still 6 over, but now it's 31. Okay, my green, again, nothing changed, so it's still 8, but now it's over 31. Yellow, now it's 1 less, so 17 over 31. Okay, cool. So let's just read what the question said. Draw a tree diagram to represent all the probabilities. Show the probabilities associated with each branch. Okay, so the probability associated with each branch is literally what we've shown on this. Okay, let's just put what the two outcomes are for each one. So here I can have red and red. This is red and green. Red and yellow. This is green and red. Green and green. And green and yellow. Okay. This is now yellow and red, yellow and green, and yellow and yellow. Okay. 8.3. Calculate the probability that the two balls drawn from the bag will have the same color. Okay. So the probability of that happening, let's see, right? The probability of me getting red and red, and or green and green, or yellow and yellow, right? I'm gonna have to find the probability of this, the probability of that, and the probability of that, and add them all together. Okay, so let's start with this first one. Okay, this is 8.3. So I need to add the probabilities of red and red plus the probability of green and green plus the probability of yellow and yellow. Okay, so the probability of red and red, let's see, 6 over 32 times 5 over 31. Okay, so 6 over 32 times 5 over 31 plus the probability of green is now 8 over 32 8 times 7 over 31. Okay, so 8 over 32 times 7 over 31. Okay, and the way I'm getting these values is just by following the branches, right? So here's red and red, so I took these two. Okay, let's look for green and green. I took this branch, that branch, and I just multiplied those two together. Okay, now for the yellow one, I'm going to take that branch and that branch, so it's that and that. Okay, so 18 over 32 times 17 over 31. Okay, now I'm just going to put all this into a calculator and see what we get. Okay, so 6 over 32 times 5 over 31 plus 8 over 32 times 7 over 31 plus 18 over 32 times 17 over 31, and that gives us 49 over 124. So 49 over 124. Okay, so that's the right answer for that. Okay, let's now look at question 9, which is probability. So it says, on a flight, passengers could choose between a vegetarian snack and a chicken snack. The snacks selected by the passengers were recorded, and the results are shown in the table below. Okay, so we have a table. We have the snack that they chose and whether they were male or female. Okay. Was the choice of snack on this flight independent of gender? Motivate your answer with necessary calculations. Okay, so how do we know if two events are independent? So let's say I have two events A and B. A and B, right? Now, if the two events are independent of each other, the probability of A times the probability of B is equal to the probability of A and B. Okay? And if they're not independent, then they won't be equal. Okay? So let's see now whether your gender, whether the snack was dependent on gender. Okay? So let's choose an example, right? Let's choose our events A and B. So let's make event A being vegetarian. So you chose the vegetarian snack, and let's make event B being male. Okay. So the probability of being male, was 67 over 150, right? That's the probability of being male. Okay, so 67 over 150, right? The probability of taking a vegetarian snack was 32 over 150. Okay, 32 over 150. Now the product of those two, so the probability of being male times the probability of taking a vegetarian snack was 67 over 150 times 32 over 150. Okay, now let's just simplify that. So 67 over 150, just using my calculator to get the answer, times 32 over 150, that gives us 0.095. Okay, 0.095. And the probability of male and taking a vegetarian snack was 12, right? Because these people were both male and took vegetarian snacks, so it's 12 over 150, right? And 12 over 150 is the same as 0.08. Okay, so you can see that the probability of male times the probability of taking a vegetarian snack is not equal to the probability of being male and taking a vegetarian snack. Okay, so therefore the events are not independent. Okay, cool. So make sure you actually state that conclusion, because there's marks for stating that, and make sure that you say that they aren't equal. Okay, cool. Let's look at 9.2 now. 9.2 says, for any two events A and B, it is given that PA and B equals to what? 0.12, and PAOB equals to 0.83, and PB, okay, PB equals to 4 times PA. Are the events A and B mutually exclusive? Okay, what does it mean to be mutually exclusive? It means that if you pick A, you can't pick B. Okay, and if you pick B, you can't pick A. Okay, so an example of this would be choosing between maths and maths lit in school, right? If you do maths, you can't do maths lit, right? And if you choose maths lit, you can't take maths. Okay, so that's a mutually exclusive event. You're picking one over the other. So that means the probability of A and B should be 0, right? Can you get anyone doing maths and maths lit? No, you can't, right? So Let's look at this question now. The PA and B equals to 0.12. So therefore these events are not mutually exclusive because PA and B is not equal to 0. Okay. 9.2.2. Calculate the probability of B. Now here we're going to use that this rule here, right? That the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay. So let's read the question again, and we're given most of this information, right? So A or B was 0.83, right? There's it there. The probability of A is, well, it's an unknown. Let's just leave it as PA. The probability of B is 4 times PA. Okay, 4 times PA. And PA and B is 0.12. Okay, so let's solve for PA here. So I'll just bring 0.12 to that side, and then we can divide by 5, because when I add this together, I'm going to get 5. Okay, so 0.83 plus 0.12 divided by 5. And that gives us a probability of A equaling to 0.19. Right? And we know that, and we are asked to solve for PB. But we know that PB is just 4 times PA. Okay, so therefore it's 4 times 0.19. And that's equal to 0.76. Okay. Next one says calculate the probability of not A. Okay, so that's simple. Think about it. The only way to be not A is if you anything but A, right? So the probability of not A is just 1 minus the probability of A. So it's 1 minus 0.19, which was 0.19, 0.81. Okay, so that's that.